Hello gang, Mr. Comp here, and today I'm going to be talking about position versus time graphs. A position versus time graph is used to show an object's position as time is moving on. On the y-axis, we have the position. The y-axis is the axis of the graph that is vertical. It goes up and down. So in a position versus time graph, the y-axis represents position. Therefore, the x-axis, the axis that runs horizontal from left to right, is representing our time. So this graph is going to show moving man's position at specific times. One important position on our graph is what we call the origin. The origin is a location where we are going to call the position 0. For the moving man simulation, notice he is currently at the origin, a position of 0 meters. So if we were to collect data for 4 seconds as moving man was motionless, what would it look like? Well, let's see. If moving man is motionless at the origin for 4 seconds, notice the graph is just constructing a completely flat line. This is showing that his position stays at the origin for 4 meters. Now what would happen if I were to move moving man from a position of the origin all the way over to the house over there, a position of positive 8 meters? Notice he jumps all the way over to the house. Now let's collect some data for the next 2 seconds. Notice once again we have a flat line, but this time the flat line is at a position of 8 meters. It is further up on the y-axis. It is still flat because he isn't changing his position from 4 to 6 seconds. He is still staying still. So what would it look like if we changed moving man's position from 8 meters to negative 8 meters, where the tree is? Let's see. Once again, we see a completely flat line, which means moving man actually isn't moving. He's staying at the same position as time is going on. But notice we crossed past the origin this time, and he is on the negative side of the axis. The negative side of the x-axis, or y-axis, is telling us that he has a negative position. In this class, we are going to say anything that is to the right or above the origin is a positive position, whereas anything to the left or below the origin is a negative position. So just because the line went down doesn't necessarily mean moving man moved down. He went to a negative position, which we said is to the left of the origin. And what would happen if I brought him a little bit closer to the origin, a position of negative 4 meters? Notice moving man moved to a position that is closer to the origin. And what happens is our graph, our position, gets a little bit closer to the origin too. So when he moved from negative 8 meters to negative 4 meters, he is now closer to the origin and remaining motionless at a position of negative 4 meters. Another important term that we are going to be discussing is something called the y-intercept. In mathematics class, the y-intercept is where your graph, your line, is going to be crossing the y-axis. But what does it mean? Well, for a position versus time graph, it is going to be representing the starting position of moving man. So if I were to reset this, and we put moving man to a position of 0, well, that is what his y-axis is going to be. He starts at a position of 0, so his y-intercept value is 0. The graph starts at a position of 0. What if we were to move moving man to a position of 8 again? And we reset. If we started moving man at a position of 8, now notice the graph starts all the way up at a position of 8. Therefore, the y-intercept is a position of 8. He starts at that position. If I reset once more, and I move moving man to a position of negative 5, and hit play, moving man's y-intercept is now going to be negative 5. The graph starts at negative 5 on the y-axis. Another important value that we're going to discuss is the slope of the graph. Slope in math class and also in physics class is a measurement of how steep a line is. When you're thinking about how steep a line is, think about a hill. If a hill is very steep, it has a large incline, meaning it is very difficult for you to climb it. If a hill is not very steep, then it doesn't have much of an incline and it's pretty easy for you to climb up. If we were to look at the position versus time graph that moving man is creating, you notice that the line is completely flat, meaning the line is not steep at all. If the line is not steep at all, that means the slope is going to be very, very small. As a matter of fact, if this line is not inclining at all, if it doesn't have any steepness, that means there is no slope. The slope for moving man is going to be 0. So when you guys are looking at graphs, it's important to figure out how the slope relates to the motion and how you can figure out what it is telling you qualitatively. So qualitatively, I can tell that the slope is 0. But what about quantitatively? How can I put a number to the slope? There's 3 ways that we can find the slope of this line. One way is by saying that the slope is equal to rise over run. What I mean by rise over run is how much does the line go up divided by how much does the line go over. By looking at this graph, you notice that it starts at 5 on the y-axis, but it also ends at 5. That means that the line did not rise at all. The y-intercept value may be 5, but from the beginning of 0 seconds to the end at 4 seconds, the line doesn't actually rise or fall at all. Therefore, for this equation, you're going to have a slope of 0. The next equation that you guys probably are familiar with from math class is delta y over delta x. In this equation, that symbol delta means the change in. So we can also say this equation is representing the change in y over the change in x. Well, another way that we can write that is y2 minus y1 over x2 minus x1. What this is kind of representing is the second y coordinate minus the first y coordinate over the second x coordinate over minus the first y coordinate. If you're not sure what I mean by coordinates, if I pick 2 points on this graph, the beginning and the end, I can write them in terms of coordinates. So for instance, all we are going to do is we're going to designate the x value and the y value at this first position. The x value at the first position is going to be 0 seconds. That is the x coordinate. The y value for this coordinate is going to be 5. So the coordinate is 0, 0 seconds, 5 meters. For our second coordinate over here at the end of the line, what do you think the coordinates are going to be? The coordinates will be 4 seconds, since the x value is 4 here, 5 meters, since he's at a position of 5 meters at 4 seconds. So when we're solving this equation, all we're going to do is we're going to take our 2 coordinates and plug them into the equation. What we end up with is 5 meters minus 5 meters over 4 seconds minus 0 seconds. In other words, 0 over 4. If we did the math, you would find that the slope is 0. But what is this slope telling us, this slope of 0? Well, it's relating the change in his position to the change in time. It is saying that as time went on, there was no change in position for that given amount of time. Thank you. If you have any questions, just feel free to ask. Bye.